Hey guys, back at the chain rule. Alrighty. So the first one video we just kind of explored, and now we're going to get into some real examples that you're going to have to duplicate. So um, we did some explorations. Here we go. Now we're going to get into some better problems. So to make the notation a little easier, because the h of x and the f of the g and all that stuff, a lot of times what we do is we use u instead of g of x, and that is our inside function. And so a lot of times we also use u prime, and we use dx to represent the derivative of u, or sometimes we just use du to represent the derivative of u. But when you have a function that is a composition, that's this line right here. When you have a function that is a composition, we want to take the derivative of that function, you basically do f prime of u times the derivative of u. Okay, so you do the derivative of the outside function times the derivative of the inside function. Okay, so let's look at a couple of examples here. Technically, u in this one would be 5x plus 4, and du would just be 5. And that part you don't have to put down, but some people may like that. It may help. All right, so y prime, I'm going to do the 3 to the outside. So there's y prime. All right. And then multiply by the derivative of what's on the inside, which is just 5. And so that's going to give me a 15 5x plus 4 squared. Let's try another one. Okay, this time my inside function is 2x squared plus 3, and the derivative of that is 4x. Right? Need a skinnier marker. All right, and so now if I want to do the derivative of the whole function, all right, so remember this is 1/2. This is the same as 2x squared plus 3 to the 1/2. So that was going to do the derivative be a 1/2, the parentheses to the negative 1/2 times the derivative of the inside the parentheses. The derivative of the inside we already figured is 4x. So again, what's inside is this 2x plus 3. Now I got to simplify this. This one's a little tricky on the simplifying. Okay, so let's just think this through for a minute. The multiplying, the 1/2 and the 4x, that's going to give me a 2x. Okay, and then this has a negative exponent, which means that's a denominator. The 1/2 indicates that's a radical, and so that's my answer for y prime. All right, let's look at another one real quick. All right, so now our inside function for this one is 5x squared. That would be my u. And so if I need to know what the derivative of u is, that's 10x. Again, you don't have to do this. Some people call it du dx. It's sometimes helpful. All right, y prime. Okay, I'm going to do the derivative of tangent. Okay, I'm going to have to look that up because I can't remember the derivative of a tangent. So you can stop the video. All right, the derivative of tangent is secant squared. So we got secant squared with the parentheses times the derivative of what's inside the parentheses. And that's still in there. Simplify this up just a little bit. Well, there's really not much we can do here. We'll just move the 10x to the front to make it look nicer. That's it. Okay. Last one. for this video. I got another video coming after this one. So just be ready. Here we go. Stop the video, let it happen. Okay, so u is 5x plus 1, and the du is just 5. Right? So to do the derivative of secant, the derivative of secant is secant blank tangent blank. Okay, and so now I've got to multiply by the derivative of what's inside, which is a 5. So remember the blank is that. And to simplify this, well, I can't really simplify this. I just move the 5 to the front. That's all you can do on the simplifying here. Because remember, tangent and secant are not multiplying anything. Well, sort of. They're multiplying right here. Here's the multiplication right there. And there's the multiplication right there. Okay, so that's it. All right, it's just math, y'all. You can do this. I'm going to do some more examples in a few minutes, and hopefully it's starting to click a little